get over to it. Let's go. No, Gant, we are not late. Gant, how's it going? Good to see you. We are not late. I was actually ever so slightly delayed in starting, and I was already sitting here ready to go, basically. I'm not sure how the stream is looking. I'm hoping it's looking fairly decent. I'm going to give a finger wave just to see how's it going. The audio is usually pretty good, but the visuals sometimes are like, is it alright? How's it going? Hey, we're not glitching too bad. We can satisfactory. And yeah, I'm going to disable preview now because I don't need it anymore. Cool. So just to discuss what's going on in front of me, this is the LED control module, everything. In fact, I actually do need that preview. I take that back. Hey Liz, how's it going? I'll tell you what, I don't have a woofler like Scruff or Big Clive, but I will take my flame on the half hour. How about that? Be my own version. And anyway, so I got a sticky note to keep me on track today because it's kind of a lot. And I knew this was going to take a minute to discuss because this is one that I've actually designed, or not fully. So that's what this discussion is going to be about. So let me start you off at the very beginning with not that or this. We're going to talk about just this. This is basically the original like attempt, and you can see I use the original connector and everything. Specifically, where is something I was gonna grab? That was something I was gonna grab. Is there LEDs? Oh, they're right in front of me. Wow. Okay, so here's the thing. Resistive mixing isn't the greatest on LEDs. It works for incandescent bulbs because, you know, you're limiting the current. Hey, Pancakes, how's it going? Good to see you. I see you on the chat. I'm having a look over my shoulder for YouTube chat. So let me get power. I've already got everything kind of nearby. And I want to step you through everything to date. We're going to go over the whole thing. Why? Because not everybody has seen everything to date. So we're going to cover it all. Got to get the power. Give me juice. So, I want to make sure I don't have the wrong voltage. That's 12 volts. Perfect. Good enough. Alright, so to start with, we have 12 volt power and ground. Let's pick one. It doesn't really matter which. We're going to do red. We'll do the red one. Alright, so watch your eyeballs. You should be able to see it just fine. Red, cool. Alright, this is full brightness. And the thing about full brightness, well, there's no control over it at all. And you can imagine, you know, you got to ground each one separately. If you want blue, you ground blue. And if you want green, well, you ground green, right? So the problem with that is I was like, well, I want to be able to control it. So I took a potentiometer, and I guess I could have used that one, but I want to leave that circuit intact. So I put that there, and instead I'll put that same red one on the middle wiper, or the side wiper, that'll be better. And from here we'll go from the middle wiper, and that can be our ground now. Now when you use the knob, let me turn the overhead light off. You can see it works logarithmically. First it's, oops, that's still bright. It starts off dim, and then it just gets really bright out of nowhere. Like you see how it steps, and so there's no control there. All right, well, the next step, watch your eyeballs, incoming light. Incoming, cool. All right, so the problem with that, there's no real control over it. So then the very next step, and I guess the easiest thing to do would be to power this other circuit that's already built. We made this circuit here and it's based off of this breadboard, right? We needed a circuit that could handle getting rid of the logarithmic brightness and make it just a nice straight linear line. So that's what you need pulse width modulation to do that with a diode. And there's an explanation for that. It's the amount of on time, and like it goes in a square wave, and the wider the square wave, the more on time, the brighter it looks, the more narrow the square wave, vice versa. But anyway, so I downloaded this schematic, breadboarded it. It was backwards and it wasn't quite right, so I changed out the diodes to fix the knob to where the knob was correct. And then I found out that it wasn't bright enough, so I changed out the transistor. The capacitors needed to be minorly adjusted. I believe I dropped the value of one and the other one stayed the same. I can't exactly remember on that. So that was, this first prototype was with the 2N2222. This prototype upgrade is the S9014. So it's a little bit more juice. And then, of course, if we power this circuit, give it 12 volts, and we can plug this strip in just because I made a connector for it. You just plug that strip right in. And when you flip a switch on, I'm going to turn the overhead off, incoming LED color, boom. So now we have red. And if you note, look how much smoother that is. But then you see the brightness. Hey Brad, how's it going? I'm glad you swung in. So the brightness wasn't all the way where it needed to be. And so that just wasn't satisfactory. Incoming light in like 2 seconds. So what I need to do then is, well, make it brighter. So that's where this other circuit comes in. And I'm not going to be able to demonstrate it, I don't think. Am I? Can I? I don't see. Yeah, I'm not going to demonstrate that because of the fact that, well, that is this circuit literally, and it's in my way now. So that's literally, we've gone on a journey from knobs, basic just resistive mixing, which was not very good, but I did it anyway because I wanted to proof of concept, to the first design off of this schematic, to a re-engineered breadboard design, to now we have an actual control module. And this is, again, this is for my kids, so I tried to make it as like all the controls hidden as possible. So I want to assemble that. Let's see what we can do to put it together, and hopefully it'll work. That's what I want to find out. Does it work? So yeah, that's the update. You know, I've been waiting on this thing for a minute, and it finally got here. But I had to resist the urge of putting it together before getting on live. What do we need? 1K resistors. So the other update, I heard back from both Ben and Anna from the shipping, like the company that ships those modules, and they are going to, they said they expect it out early tomorrow. They're going to ship out the correct module. So that was really cool. They were really nice. Like, just in case anybody ever wanted to know what the customer service was like, I would give it a 10 out of 10. They were real friendly, and they keep in contact, which is cool. Not a lot of customer service will follow up contact. The good ones do. But so it was a really, I mean, it was a painless experience in terms of like, hey, here's an issue, and the issue's dealt with. In terms of the issue itself, that did kind of hurt my feelings a bit, because I had this excited, like I was waiting on it for a month, and I got this excited bit about me when I saw it in the mail, and I'm like, that package seems a bit small, but I was too excited to care till I got home and opened it up and realized, this seems off. But the bright side is, first off, I could keep it. That was really cool because I did offer to send it back. But I get to keep it, and I played on it last night, kind of goofing off. That's when everybody decided, yeah, this is a good time to leave. So, yeah, it sounds pretty cool. Everything works on it. The new LED brightness is much better. I do like that I used a 510 instead of a 1K resistor for the brightness. So, as a kind of a flashback, anybody who was not privy to that last build, the safety valve number 2 was when I decided to go ahead. 100 picofarad, what is that? I reduced the resistance a 101. Well, I've got those. I switched the resistance in half because the brightness was very, very dim, and I believe that's because the module that is designed around a red LED, and I used a green, and I believe the green LED does take more juice to actually be the same brightness. I could be wrong, but I'm gonna assume that that's the case because if I'm not mistaken, it does take a higher forward voltage to turn on too. But I'm not an expert in LEDs or diodes or anything. I'm a trained dumbass. But anyway, this is a circuit I was really excited about because this is kind of out of the norm. Normally I'm not designing control stuff. I'm messing around with audio stuff. We need a nanofarad. That's a 102. Do I have 102s in here? I do have 102s. We need 3 of those. Did I really grab 3? Wow, that was the most luckiest grab in the world. It'll never happen again. Well, mathematically speaking, it's bound to happen again, but I mean, that was a metaphor? A saying? I don't know. Pick one. I also had some other stuff on the way that made it today, which are these barrel jacks, so I can actually power it up super easy. Now we need some transistors. This one uses the SN901 pole, which I have right here. If I can remember which one it is. That's 3904, S9013, 90, S9014. There we go. Oh, I had to find you there. I cannot read that print. That is very tiny. I want to make sure that I get 3 of the correct ones because, you know, these ones aren't as segregated as my capacitors. The capacitors have these like little grid thingies on the lid here. This one does not. Trying to design everything. Look at that. Oh, I love it. I can just keep popping these in. My soldering iron is ready to go. Waiting on me to finish spreading legs. I mean leads, you know, the components. Is it the half hour yet? Not 15 more minutes? Cool. Alright, we need diodes. I've got plenty of those. I love my new drawers. Without reading glasses. Yes, I'm telling you, I'm getting there. I have glasses that I'm supposed to wear, but I don't because they're just not helpful. They messed up one of the 1, 2, 3, 4, 5. You know what? Those are all the ones that are like already crinkled and stuff. So we'll use those, and then I'm gonna pull the ones off the breadboard and use those. I guess I could have made this a little more compact, but I'm not a professional. I am not a professional. I'm a getter done. Does it work? If it works. To be fair, like people like Brad on his channel, he does guitar amp repairs. I actually love those videos because I take notes. I'll be sitting there going, okay, let's not piss off the text by doing that, or that, or that. Cool. I will remember those things. So, for what it's worth, Brad, I do appreciate your videos in regards to hopefully stopping future engineering mistakes. I know I'm not going to build a Fender amp. That's anyway. I only need one extra diode. That's nice for now. I mean, I got to build that other one. Grab that diode off the breadboard because I know that's already like trimmed down and waste not, want not. There's nothing wrong with it. It's just got a little bit shorter legs, so it needs a little assistance, like getting it realigned with this setup instead of the breadboard. Alright, I believe that's everything except for the sockets, which I'll do last because it looks like a jungle in there, full of legs and leads. I love that. I was literally looking on Amazon to check on an order. I ordered some 12 volt, the barrel plugs, not the socket, but the plug that goes on the wire. And I was checking to see where they were at. And the first recommendation in the list was one of those solder spool holders. And I said, get out of here. I paid like 1 penny. I don't think I even paid for it. I think I found it on the ground. It's like a construction screw that's long enough that my solder reel just slips right over it, and it's mounted on the board above my head. So it just, I don't know, I feel like that was a free, that saved me $11.99 in shipping and handling. Maybe stress of it not even getting here, that happens. Oh wow, I'm gonna have to do the transistors after I trim the forest. That is in there. That is in deep. And if I did the module design correctly, it should work. But you know what? I'm just saying, my luck is not perfect. I tend to have that luck that's 50-50. Maybe it'll, if it fails, it'll blow up in a spectacular puff of smoke, you know? That's what I always hope. If it's gonna fail, at least fail nice and shiny, you know, like blow up. Do something fascinating. Don't just sit there and not work. Because that's maddening as all crap when you're designing something and it won't work and it's not doing anything. No indication, nothing's getting hot. Your like power supply is not giving you a short or anything. Like, you feel that pain? Anyway, so hopefully this one will either work or maybe blow a capacitor or something, because that's always fun. And I've got plenty of them, so it's not really going to hurt my feelings. I'd rather not. I'd rather it work, for the record, you know. But I mean, just saying, I'm okay with it blowing up too. I've had plenty of things do that. Actually, when I designed that Halloween synthesizer, I had like 5 capacitors blow up after it sounded extremely, very much Halloween, and that was, turns out, the sound of capacitors dying in auditory form. The sound of the capacitors dying was coming through the audio, and you could hear it, and they were like squealing and sounding very like House of a Thousand Corpses type. And I'm going, this is really cool. Pop! And I'm going to tell you something that doesn't leave this stream, unless you, I guess, tell somebody. That it exploded. It was like a 1 or a 10 UF. I think it was maybe a 10 microfarad. It was a big capacitor. And when it went bang, when I tell you I fell on the floor thinking I was getting shot at, I swear I thought I was getting shot at. Oh, my hands are shaking. Don't shake. But yeah, it scared the mess out of me. I said, oh. I fell out of my chair on the floor. I thought I was under attack. I said, oh, emotional damage. It got me too. Oh, it scared me so bad. If there would have been somebody in the room with a camera on, that could have been one of those viral videos. Because I didn't just jump. I jumped and fell out of my chair, like on the floor. It hurt my hip and everything. That was rough. Let's trim those in the trash, because usually when I trim 3 at a time, they go flying everywhere. Already everything looks soldered. I really don't like how close those pads are on transistors, but I didn't go back and redo those like a smart person. And because these are 555 timers, I don't want to use a socket on them. Does that make me a bad person, that I don't want to use a socket on them for this board? I feel like that's a waste, because I use TLO72s in synthesis, and if they blow, it'd be nice to be able to just quickly replace them. And this is just an LED control module. I don't know. We'll do it without sockets. It should be okay. Don't hit me. If these weren't 555 timers, which I've got like 100 of, I wouldn't do this. But I don't want to waste sockets on a LED control module. I feel like that's the bigger waste there. I don't know. Somebody might have an opinion on it. Either way, my hands aren't going to get it in there without assistance, because they're shaking. So we're going to go it this way. Did that work? I think it did. There's that one stubborn leg that's like clinging, like the lobster that doesn't want to get cooked. I am not a crook. But yeah, it's almost half hour, and I will take my woofle break. 6 more minutes. Have to keep an eye on it. Oh, Liz, you were there for Scruff's giant woofler. Look, I feel like if the wind weren't fighting him, right? That's number one. And then I had an idea, a conceptual idea. I hope Scruff Dog, he may not make this stream because he works during the day. Liz, if you're still here, pass this on to Scruff somehow for his woofler idea. I've got, if he were to add, like, say, 3D printed tubes, a way to get oxygen to the base of the foam. You know, maybe have the tops of the tubes at the rim and then kind of flow under the 3D print. You can do that in the design. You could 3D design it to have like a straw, a tube, whatever. Food for thought. Let's put that 4-pin connector on now. Wait a minute. Let's double check that orientation one more time. Cool. 12 volts, 12 volts. Right on. When I designed this thing, I was more proud of the fact that everything could be sourced easily. That was what I wanted, is something that everybody could source their components. If you're a very beginner, all the way up to you know, whatever. People far beyond me. I figured through hole, 555, easy connectors, something everybody could get their hands on, inexpensive, reliable, right? Everybody can get their hands on all of these components, I feel like. I mean, nothing costs more than 50 cents. Except for maybe the power supply that you plug it in the wall. I didn't even think about that for a second. So we've got one board assembled except for the power, which I'm going to use one of the new ones because I like the fact that they're They got a bigger connector on them. Oh, that's got tape on it. Ah, I'm so proud of this design. I hope it works. If it works, we're in business. And I put a barrel connector on it because you can buy them, you know, inexpensive. They don't cost too much. I think I paid maybe $3 for 20 or however many that was. Oh, my hand went derp. Derpy hands. Ah. Grasp firmly. Grasp firmly, young grasshopper. I'll stick it in there. Oh, mercy me. I just need a little bit of an anchor. There we go. I just needed enough to anchor that in place because I'm not skilled like Clive. Not at all. Those hands, I shake. I shake so bad you don't. I would put a certain brand of personal massager out of business. I just do really well at hiding it most of the time. And you don't need this side one, but I'm gonna put it anyway because I don't want it to like do some wonky bendy stuff. Cool. Ba-da-ba-ba-ba-ba. So let's get some knobs. Put them in now. This is exciting. I've got my own control module. This is probably my first non-audio PCB design, I think. Everything else has been either a guitar pedal or a oscillator or a filter, amplifier, something. I've built VU meters and LED flashy thingies, and like I've built a super sphere, all sorts of LED stuff, but I've never actually built a non-musically. This thing is going musical too. Somebody in the comments of the video I uploaded suggested adding control voltage. And when I tell you that that is a brilliant idea, and I'm probably going to add control voltage to this module and make a synthesizer version of it, probably going to do that. When? Don't know. But it's on the list. That is one of many things still on the list of projects to do. So, yeah. That's going to be, I would say that's going to be really fun, because I want to add it to where I can say do a low pass for maybe red, band pass for the blue, and high pass for the green, right? But then only have one control voltage in. And I thought about even having the option, like have a microphone. I've got a bunch of condenser mic caps, like the really good kind. I could put one of those on the back of it as a, and you could put a switch on it, right? And switch between ambience, whatever it's hearing, whatever vibration, and then control voltage. You have either one of those as an option. Food for thought. Again, just all sorts of ideas always flowing, but actually putting them to use sometimes can be tricky. It very much can be tricky. But I'm actually proud of this one. It got all the way done. All the way start to finish. And did not get interrupted. And for ADHD, that's a big deal. Oh, you know what? That is the truth. Cool. Let me get over here with my flux pen. 'Cause we are the champions, my friends. James, how's it going? I'm glad to see you in the stream. I haven't seen you in a minute. I hope you've been doing good. I have been very, very much away from social on Discord lately, so I apologize. I haven't checked in lately. I have actually been so swamped. Alright, so we're putting the face panel on. Let's go. Oh, I love it. It just drops together. Let's go. Let's bolt this together. Let's put some bolts on it. Start making it look nice. I'm so proud of this module. The only thing that would make it better is if I would have went ahead and designed the CV version. I'm going to make a CV version sometime soon. I might do a live stream bit, like just design on it, just sit and chat and design that joker. Somebody might see something and throw out some idea. That happens a lot. That's why I do the live stream builds, because there's always something funny happens. You know what happened today? The cameras are not causing massive lag. Busy at work lately. I missed you too. I actually missed chatting with you on Discord. I will have to take a vacation from engineering and videos for a while though, before too long, and start catching up on social. I've got several friends that I haven't talked to. I don't even talk to people that are living on the property with me. I talk to them maybe like once every few days. Like, hey, how's it going? Cool, I'm busy. I'll talk to you later. It's really because if I don't stay busy, I have anxiety, and anxiety sometimes can be pretty loud in the stillness. So I try not to stay still. Anyway, that's totally something that doesn't matter. We're gonna get there, and this module's looking so, oh, I love it. I'm very proud of this thing. I'm proud of it because I can say this is mine. I can proudly say that this is mine. Just, there was only one other module that's physically done and working right now that I can say that, and that's the Cinco de VCO. So let's, before I shove knobs on it, we should test this, right? Make sure it works. I may have missed the flames. Oh, you did not miss the flames. I don't have an actual woofler. I have a 420 woofler. I got flame on though. We flamed on, no worries. But yeah, you didn't miss anything, I promise. I have like two different streams going. I've got my personal profile on TikTok going, and then my public, I guess they're both public really. I'm just a public person, whatever. But I've got two different streams going. So I'm watching chat. Hey, how's it going? You haven't missed anything, Chris. I see you. I'm actually putting in the last bead of solder there, and it's done, just like that. And I'm gonna turn this off and put a little dab on here to keep this thing looking brand new, like it has for the last couple of years. All right, so we now have, let's turn this around. We have Control Module V1 ready to go, looking nice. And we don't have the knobs on it yet. Let's test it and see if it works. Does it work? Here you go, Chris. Since you're not actually in the YouTube side of things, this is the control module we've been building. This is version 1, and this will be the first test to see if this module I built works. This is the replacement. The nice. Hold up. Let me. Where is it at? First, let's walk you through. First, I had this resistive mixer, which basically it's just a knob between ground of the LED and the ground, power ground, to limit how much it can turn on. Didn't work so well. Then we made this thing. You've seen this one on the videos already, I'm sure. So then we re-engineered it and made our own very own nice module. So we're about to test it and find out if it works. If it works, Great. And I have some 12 volt power. 2.4, 12 volt to it. Well, here goes nothing. Do we need all of this? We don't. We could just pull out one. Somebody's going to get mad at me for doing what I just did. Alright. Yep. You're seeing me butcher this wire. I do that a lot. I'm just going to cut that thing. It's in my way. Plug it in. Plug it in. Alright. Is that a DC power? Let me make sure that's DC power. Output 12 volts. It's not reassuring. Alright, so we need to plug LEDs into it before I turn it on. Let's plug these in. Oh, this is the nerve-wracking part. Is it gonna work or is it gonna blow up? Is it gonna... Let's turn off the overhead light. I'm gonna hold on to the power and rotate this camera just a smidge, and overhead power. Let's see. I'm gonna prop this. I'm gonna prop it so you can see it on the TikTok stream a little bit. It'll be very hard to see, but that ought to be good. All right, plug it in. Hey, it's plugged in. There's juice. There's good news and bad news. Oh wow. Oh wow. Oh wow. Oh wow, it's so bright. It's amazing. So here's the good news. It works. Look at this. We designed it. Take care, Dave. Roger that. Take care, Liz. It was great having you. Look at this. We have a working control module. We designed from scratch. Here's the bad news. The diodes have to be reversed on the schematic file, and then I have to order a whole new board for the face panel. No, I have to switch the okay, let me rephrase that. There's two options here. I could go ahead and switch the diodes on the physical board itself so that... Oh no, the diodes are fine. The diodes are perfect. It is dim, bright. Dim, bright. Cool. Left, dim, right, bright. The on-off switches. That was the one. The on-off switches are backwards. It's off to go on and on to go off. We screwed... I say we. I screwed that up. So, damn. I gotta reorder the control board and make a V1.1. 1.1 is be a revision number. It's not a whole new design. It's just fixing the switch. That's unfortunate. But it works. Is it getting hot? Nothing is getting hot. There's no warm resistors, no warm transistor. 555 isn't warm. But it works. I'm pleased with it. It's nice and vivid and bright. It's not dim like that other one. We can mix our colors now. Let's see, that's red, so we'll put in, say, some red and then flip over here to some green. Add purple. How about that? So our design works. Let's try adding green to make orange. Yeah. Orange and then more green. So yeah, it works, but I've got to go and redo the switches. That's a shame. But hey, you know what? If that's the only thing wrong is the switches, that's not really a bad thing, is it? I mean, it's not good for selling, but it's fine for the kids. So that means every one of those boards are gonna be that way. That is really cool that it works. All incoming lights, watch your eyeballs. It's about to get really bright. 3, 2, 1. We have a working module. What's up? So, do I care Yes, I do care. I'm gonna have to redo that. That makes me ever so slightly irked because I have to go and redo it to make my own OCD happy. It cannot be off and on. No. We are not gonna do all on and off. On, off. That's not cool. How did I mess that up? Let's, you know what? Let's break up kicad. Mistakes happen. This is why I do them live stream. You know, they happen, but we have it works. Hey, it works. Everything works. The switches are backwards. So what? I could actually, you know what? I could even cheat. I could just order a new face panel that says off and on. I could do it that way. It's for the kids' learning purposes, so it needs to be correct though. So I'm gonna go fix it right now. Control module dot pretty. So we got a open project. You know what? Hey, you guys can see the screen. I'm gonna share. This is the control module. You guys can watch me fix it. How about that? So for the switch, it's the switch that's backwards. So we need to connect these up is what we need to do. Well, not that way, of course. There. I like that better. I'm already happier with that. Oh no! It mustn't damage. You know what? This is gonna bug me. This is gonna bug me. There we go. Cool. Now we can hit save, and then we'll want to go run PCB new because I guarantee it's not that simple. You got to go. You can't see what I'm doing over on TikTok stream. I do apologize. I'm redesigning this control module. I can't, there's nothing I can do about camera view there. Oh, let's see. So, well, that's an easy fix. Look at this. We can just delete this trace, delete this trace, delete this trace, and then we will update schematic. Update. See, it moved everything down. We'll go over here and do a 0.35 from half. Those were green. Let's stick to green. Does it matter? To me, yes. Save, and then we'll put that back and hit B so it updates all of our masks and everything. And then we need to go to silkscreen, and this needs to be changed to 1.1, not 11 or 0. What in the world? Be 1.1. Cool. Save. Do all our generates, close, plot, close, and then we'll go back to OBS and go back to screen record. And yeah, we have now fixed that problem. It will not be an issue. So in the meantime, I want to keep the face panels. There's nothing wrong with them. There's no reason to toss them aside. So what I'm going to do, I'm going to take these control modules, and I'm going to set them aside in my prototype bin because there's nothing wrong with it. It works. If I need one and I don't care about switch orientation, I've got one already assembled that I don't care about switch orientation. Right? So, for the sake of my kids learning red, green, and blue and seeing it with their eyeballs and everything being correct, I do actually need to wait. Oh no. Yeah, while I'm at it too, we're going to fix another design flaw that I just now noticed. On the back of this thing, you can't see it. Let me hold this up so you guys can see. Can you tell? What's up, Scruff? So it works. You did miss the actual test. Nothing too wrong. The camera stream should be working this time. I did some changes. I took your advice. Scruff Dog is like, he's like my wingman. I'm serious, like he's a real pilot. Anyway, so but issue, we fixed the first issue of the switches backwards. That's fine. You hurt my feelings a little bit, but you know what? Whatever. The other thing, look over here. The mounting hole. That's shaving it really close. It fits. It will fit. But if I'm gonna buy a new set of control boards to fix the switches, this would be a really good opportunity to shift the whole board over. Camera is much better, thank goodness. You know, here's what I did, Scruff. I lowered my face cam to the lowest possible resolution I could get it to, and it's still like be visible, like just visible. That was the only goal there. This camera, this one, I had to put it on 720. It's on 720p. That was the only thing that worked. I did 3 or 4 test streams, like unlisted test streams, to finally get the video to not be choppy and laggy. And you were right, it was trying to do too high a resolution on too many screens. If I were going to add another camera for a third camera, I would have to, instead of using the USB capture card, I would have to buy a PCI Express capture card meant for that purpose and use my camera. And even then, my video card would need to be upgraded because, yeah, the video card is what's doing the rendering, I think, and it can't handle it. At least it works, though. Since you missed it working, Scruff, I'll show you. It's backwards. The switches are backwards, but otherwise, we plug it in, and then we plug our LEDs in. Just, you know, like so. And then we got switches and knobs. There's blue. That's hard to see on camera, but I'll cover it like that maybe. So there's the blue one, and then we got the green one. That's really hard to see. Oh wow. There's my camera. Green. Hold up. How do I do that? I'm sorry. Till I can do a full, yeah, roger that. I'm gonna keep everything settings wise the same. That's very, like, really rich green in real life. I don't know why it looks white on the camera. Maybe it's my surroundings. Anyway, so there's the green one, and then the red one. And you see how much brighter that is than the old module. Like, that is significantly brighter. So I'm really loving it. Let's talk later about an update to your. I swear, I felt that. All right, so everything's kosher. Mercy me, mercy. So here's our DIY control module that does need revision, which, you know what, considering that it didn't blow up but it worked, that's a victory. I'll take that. I'll take that. Watch your eyeballs. Incoming light in just a second. 3, 2, 1, 0. Bright lights. I will never forget that warning if I can help it, because I swear nothing sucks worse than squinting at a dim screen to see a stream and then all of a sudden, mercy heavens. So I've already switched the schematic files, so the schematic is up to date. I have not updated the shared works folder, so if you guys have already downloaded the files, hang tight, don't use it. Let me update it and then re-download. I'll leave the other one. No, I'll delete it. I'm going to delete it and put the proper one up there. There's no sense of keeping one that's reversed. But anyway, so it works. The only thing is the face panel doesn't match the switch. You know, it's on and off. On and off. So I went in the schematic and changed that around. Went ahead and updated the design. Did a new, like the plane and everything. The only thing I'm not too happy about, but it's fine looking at it straight on, is how close I cut that right there. This corner is too close. This one's all right. I would have preferred there to have been more this way. So I have very limited space, but I could shift it this way about 3 millimeters. I might just need to wait a minute. I could move these 1 nanofarad capacitors next to the 100 picofarad capacitors, or even move them down closer to the 555, and then this whole thing could shift over. No, because then the resistors, I could just drag the resistors to the right more, and then I don't know. Now we're going to get into the realm of over engineering. It works. And it's meant to go into a panel that basically is just a hole. So you could mount it across a top rail and a bottom rail, and that would work fine. It doesn't have to have vertical pieces on it. But we engineered this. I've updated it, so that means now if I were to order another one, it'll be fine, right? Can we call that a stream? I believe. Well, I need to build a second one too. Should I? No, I can't build a second one. I gotta order the new control module for my kids. I gotta make sure it's right. Dadgummit. All right. But anyway, that's what I wanted to build today. Updates. The next couple of things. For those of you that did not catch the update about the modulation station, Anna, one of the customer service people of the shipping company that Sam uses, told me everything is being sorted. They're going to ship out the correct module early tomorrow, which is great. That'll be cool. It'll take about a month to get here. Just to brace yourself. It'll definitely be a solid month, no problem. I've also got 3 other modules on the way in between though. I've got the Twin T drummer. I finally got the drum machine, the drum module. The OBA, which is the, I think, overdrive, boost, and attenuator. I think that's what it is. Overdrive, boost, attenuator, the OBA module. And the other one just says bounce, 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 bounce like 8 times. And so I got those 3 modules. They hit international last week, so if the pattern stays the same and everything keeps arriving as it has been, that should be this week. Like, if anything, it might be in the mail today. I haven't checked the mail, but I don't think it made it today. I want to say that it's more likely to get here by Friday, but I have an appointment Friday, so I'm not going to be able to do anything, even if it gets here. But if it gets here before Friday, we'll put one of those together. I'm not sure which. Now that I can do polls, that's a cool feature on YouTube. I'll put a poll up and see who wants, like, if anybody wants to vote on it, you can vote on which module you want to see next instead of, I mean, otherwise I'm just going to pick one. I've got 3 to put together, and then if I stretch them out, let's say I do 1 a week, that'll mean there's 1 week of downtime before the modulation station gets here. And then but on April 27th marks the 1 year anniversary that I've had this freaking kit. So it might be time to put this kit together. This is an oscilloscope. I've had it so long the bag has like the you see the damage from the components shuffling around inside the bag. It's all like poked holes and gritty looking. It's just the capacitor leads and stuff poking the bag. So that 1 year anniversary will get it done. I blame executive dysfunction. And actually, since this module, I want to take this face panel off of here and throw this one into the pile of prototypes. I'm going to do that. Anyway, I appreciate you guys hanging out and watching this. This thing was really cool. I am going to put the files in the comments and update the description like within the next hour or so. So if the file does not say 1.1, don't use it. Not unless you really don't care about the switches being backwards. But again, that is not a functional issue. It's a labeling issue. So if you don't have labels on whatever you're putting it in, then that doesn't really matter then, you know. But yeah, it's all there. All the schematic files are there. So if you have KiCad and are like savvy with it and don't want to wait, you could always just update it yourself. It's really, again, it's one trace on all 3 switches that need to go from pin 3 to pin 1. So it's supposed to be 12 volts to pin 2, and you have your power is pin 1, like to the actual circuit, pin 1. So this is going up into the prototype for, I'll use it, but not for my kids. Cool. So you guys take care. Might be about time. Yeah, I need to update something. I'm still using a GeForce 660 Ti. Honestly, if I could get my hands on any new card, any new graphics card newer than that, it would probably be alright. But anyway, you guys take care, and I will see you next time. Oh man, let us fade over into intermission.